Hello everyone. For this tutorial video, I'd like to explain more in depth what a conservative and non-conservative force is. A conservative force is one where the change in energy does not depend on the path taken, such as gravity, as discussed somewhat in depth in the last video. In contrast, a non-conservative force is one where the total energy involved does depend on the path taken. For example, if you rub an eraser along a straight line path and then a more complicated path that is longer overall. The longer path involves more friction, so there's more energy lost or dissipated compared to the shorter path. We see as well that when an object hits another object, like a rock slamming on a table, almost all of its energy is wasted away as sound and heat, as well as deforming the table slightly. But for the purposes of it falling through the air right before it hits the table, we can say that it is acting under a conservative force. Even though the energy involved is more complicated with non-conservative forces, we can still solve problems with them if we know the basic definition of work, which we went over in a previous video. As work is all about transferring energy in general and does not involve specific types. So it will still work if there is heat energy involved as well. So an example is, if we want to find the energy involved in a baseball player sliding to a stop, and we are given a mass and initial speed, as well as an overall distance traveled, and that the force of friction is constant in the path, then we can plug in everything into 1/2 mass times velocity squared, the kinetic energy at the beginning, minus force times displacement of friction equals 0. We chose 0 as a final answer because the baseball player slides to a stop, so it has 0 kinetic energy. And we chose to do the minus instead of a plus because the force of friction is in the opposite direction of the initial motion, so it takes away. So now we see, with some algebraic rearranging, the force times the displacement of friction is exactly equal to the kinetic energy at the beginning. And we can now solve for ourselves the exact distance this involves by dividing both sides by the force of friction, as it was fortunately a constant in this problem. And we conclude we have an exact distance of 2.6 meters. If we have a more complicated problem involving a slope instead of a flat surface, we can use the law of conservation of mechanical energy, but we would add the work from friction because it removes mechanical energy and turns it into heat energy on the left-hand side. We know the kinetic energy at the beginning already by what kinetic energy is defined as. And we know the potential energy at the beginning since it is at the bottom of the slope and on Earth's surface is 0. And the work done by friction is negative force times displacement, like in the last example. So we set this equal to the kinetic energy at the end, which is 0 because it slides to a stop, plus the potential energy at the end, which is given here as the displacement times the sine of the angle, because it is not a straight up and down, but a tilt. So we see now that solving for distance becomes more messy because we have it on both sides of the equation, so we cannot easily isolate it right away. But what we can do is get like terms with displacement on the right hand side and everything without displacement on the left hand side, and then solve for it that way. Doing this tells us the displacement is exactly 2.31 meters. We could probably have also predicted, just by intuition, that the player slides a shorter distance uphill, because of the fact gravity gets involved. But using energy equations helps us predict exactly how far, rather than simply making a guess based on our gut feeling. Now that we've explained how to solve mechanics problems involving energy, we can discuss one final energy concept before we move on to how simple machines work, which is called power, and refers to how quickly energy is transferred. And this is sometimes also called wattage, after the physicist who first discovered the concept. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.